All right, hey guys, this is part two. If I skip any questions that you're really wondering about, just come talk to me um, before or after school. I should be here every day before the test. So if we have, if you're looking at number 12, a lot of you may want to choose geometric distribution. The reason I did not choose it is because we are not replacing that card. So right here it says turn over until you observe the first red card. And looking at the trials until the first success is a characteristic of geometric. But we talked about geometric. We can never accomplish that if we are not sampling with replacement. It doesn't say anywhere that they're replacing the cards. You're just flipping and flipping and flipping. And because it's geometric, we have no chance of checking a 10% condition, so I had to choose none of the above. So kind of keeping that in mind, the 10% condition only applies to binomial distributions. If we wanted to try to do it with geometric, it doesn't make sense because we don't have that set number of trials that we can compare to the population. So we could potentially have many trials until our first success. And in that case, we have no way of limiting it, and we have no way of checking this 10% condition. So it only applies to binomial distributions where we sample without replacement. That's usually something to do with people. We're looking at people, and we're not putting them back because we don't want to count them twice. So what it states is that the sample has to be small compared to the population. That's not when we can use it. I think a lot of you were confused with that. We use it when we sample without replacement, but the condition states that in these scenarios, the sample must be less than or equal to 10% of the population size. A lot of people think that means that we always want small samples, but that's just not the case. Most of the time we want larger samples, so the 10% condition is very limiting because we need it to be smaller or equal to 10%, but we get better information from bigger samples. Sometimes the large count condition is passed with larger samples. So it doesn't mean that smaller is better. It just means that we can pretend or assume independence and therefore carry out the problem. So I would say you're pretty much going to check the 10% condition for every binomial distribution if it's a free response question. If it's a multiple choice question, you might not, just because those ones are a little bit shorter. So that brings me to large counts. It also only applies to binomial. Geometric distributions are always skewed right. So we can never have something that's approximately normal. Many binomial distributions, however, are approximately normal. So statisticians say if it's approximately normal, we should be using normal approximations. If it is not passed, you do have to just go ahead and use the binomial CDF or PDF and use the binomial distribution. But most of the time it does pass, and on your AP exam you're expected to use normal CDF when it does pass. So it just wants there to be a balance. The number of successes is large enough, so they say at least 10 successes. The number of failures is at least 10. So 10 and 10, bare minimum that this could pass is 20. Usually it's a lot more trials for that to pass because usually we don't have a 50-50 probability. So going back to some of the other questions, this one's straightforward, just use the formulas. Number 14, never does this have to be true. B, C are both attributes of binomial distributions, and then E doesn't all have to be equally likely. So D is the one that is geometric and not just binomial. Okay, you might have questions like this. A, you had to recognize was geometric, so I just used the formula. You could have used GeoMet PDF for that. The next one you should recognize is binomial because it's 4 out of the next 9. So I was trying to see if this was enough evidence. Looks like I did not finish the problem. So what I would like for you to do is type that in, find the probability, and if it's very small, see how that determines your answer. Evidence to assume his percentage has dropped. If it's a large probability, maybe it's not enough evidence to see if his shot percentage has dropped. So let me know if you have questions with that one as well. All right, 16, I think I changed the question. I don't have the original sitting with me at home, so if you have questions on the new 16, just come see me before school. So 17 starts off binomial, which means we have to check the 10% condition. So a lot of the times I told you we're going to have this like very obscure, what is my population? And you can just write millions of Americans. Just having this is totally fine. Some people like to multiply by 10, solve it out, but this is accepted on the AP exam. So you're going to need the mean and standard deviation if you in fact can use the normal CDF. So I asked you to go ahead and calculate it here. Then I asked you to check the large counts condition. It checked out, they're both greater than 10. So what that means is this distribution is approximately normal. And because it's approximately normal, I don't want to keep using binom PDF. I want to go ahead and use normal CDF. So anytime we have this interval, you're usually going to use normal CDF. 45 to 55, then here's my mean from up above, and then here's my standard deviation. So again, let me know if you have any other questions. I think I hit on all of the biggest ones, and good luck on your test.